Greetings everyone. In this video, we'll be discussing about another important equipment of substation, that is circuit breaker. Here is to my viewers that it will give a real-time industrial exposure with valuable learning experience, and you will come to know about the other devices, equipments that are being used in substations, transformers, isolator, protection system, and in actual working substation. It will help my viewers for the classroom concept much easy to understand, and it will be very interesting to observe how power is being received, controlled, protected, and distributed at different voltage levels in a real time power system. So for an electrical engineering student, these videos will be are more of very much importance just than your academic activities, and it will help to bridge the gap between the theory and a real time practical application. So stay tuned. In this video, we'll be having the discussion related the circuit breaker, and we'll understand the classification, operating medium, installation type, and how it is being applied in modern power substations. Most of you will be knowing that circuit breakers are mechanical switching devices which are able to do the following performances under normal and abnormal operating conditions. So, normal operating condition, when voltage, frequency, current, everything remains stable in a rated operating condition, and abnormal condition, that is the fault or transients. So these are the functions and the purpose of the circuit breaker during switching, fault and isolation, protection, system stability, and maintenance. So during abnormal conditions as well as required maintenance schedule, the circuit breakers are operated to isolate the equipment. So whatever may be the equipment, substation equipment we are interested, the following five things we need to understand: the standard for which it will be manufactured, installed, commissioned, testing will be done, the IS standard, IEC standards that we need to read, study, analyze, the principal parameters, ratings and their choice, technical requirement, and testing and evaluation. These are the five things we should be focusing on for all sorts of substation equipments. So first we'll see what is the working principle. In the last video also, during the discussion about current transformer, we have come across the analogy to our human system, that the relay acts is nothing but like our brain. The CT, CVT, PT are nothing but like our input sensing organs. Similarly, the hand and leg are the circuit breaker and isolator, that is the output most of the time in a system. So how in real system the function of these uh, devices are done? First, let's assume that once fault occurs in the system, then CTs and PTs detect the abnormal current or voltage. Then the relay analyzes the fault based on the configuration, and it sends the trip command, and circuit breaker open its contacts, and arc formed between the contacts is extinguished. The faulty section is being isolated. So this is the protection chain from fault sensing through CTPT, through relay, through trip coil, then circuit breaker, then isolation of the faulty part from the healthy system. So this is the classification of circuit breaker in substation based on broadly classified into three based on quenching medium, based on voltage level, based on installation. So quenching medium, that is the arc extinguishing medium. So we can have oil circuit breaker, air circuit breaker, vacuum circuit breaker, or gas circuit breaker. Most of the oil circuit breakers are now obsolete. Air circuit breakers and VCB and gas circuit breakers are in practice. At low voltage, ACB can be used in LT panels. Medium voltage, we can go for BCB, and high voltage, extra high voltage, we go for SF6 circuit breakers. And the configuration of SF6 circuit breaker for 220 and other, the configuration is bit different and the mechanism is being different. Based on installation, it can be installed in indoors for SCB and VCBs, outdoors for high voltage circuit breakers. Similarly, the substation applications is the overall uh, summary. We can, for quick memory, we can remember up to 415 volt. We can go for ACB. Then 11 to 33 kV, we can go for VCB. More than 132, we should go for SF6. And the typical locations also are based on the voltage level and the circuit breaker. The substation applications with the image also has been mentioned in the section 4. You can analyze that. Here I have shown a real-time picture of the 33 kV vacuum circuit breaker, and you can see the part. There is a fixed contact, fixed terminal pad which is connected to the primary side, and the output side is connected. I mean, after the moving contact, whatever you see on the right hand side, there on the other side, it is not visible on in this image, and the output terminal is on the other side. So inside there is a moving contact, which when trip signal is given, it is allowed to move based on the trip signal, tripping coil instruction, and the mechanism, the coupling system, operating system that is there inside the box. So mostly these CVs comprise of three metal clad breaker poles for three-phase system, and the operating mechanism supporting frame for the three poles. And we can have a single break interrupter or individual interrupter. So for the SF6, why we are going for the from VCB to SF6 for higher voltage, because it is maintenance free and have long contact life, reliable, non-explosive, and silent operation. Here you can see the inside sectional view of a SF6 circuit breaker. There is an interrupting chamber, the operating mechanism, the spring mechanism, the trip coil and the closed coil, the density monitor, and the auxiliary contacts that we'll see in the next video, next slide. So first we need to understand what are the rating based for the selection of breaker, the rated voltage, current, breaking current, and making current and frequency. For 132 kV, the rated current is around 1250 ampere, 2000 ampere. Based on our load requirement, it can be there. Similarly, breaking current, making current, and frequency. Most of the people have a common notion that isolator is also a switch, SF6 circuit breaker, or any circuit breaker is also a switch. Then what is the difference? Why we have two types of switches in the substation? So imagine that it is a switch which can be tripped, which can be opened automatically based on a trip signal, whereas isolator is used only to see a visible isolation of the circuit for maintenance purpose. It is only for no load operation, not for fault current or loaded condition, because we can't see the fixed contact and moving contact that is there inside the breaker, whether it has opened or not. If through some malfunctioning the contact has not been opened, but if we assume that the circuit is open, then the maintenance aspect or the fault will not be extinguished. Okay, so there is a need of isolator. We can refer our isolator video for that. So earlier that the control circuit was there. So what are the control circuit? Two different control circuits are there. I mean trip and close. Trip circuit is completely different and closing circuit is completely different. So this is the local mechanism box where you can have a local switch for operation, and a remote switch is there in the panel, in the control and relay panel. Okay, in detail we'll understand how this tripping circuit, closing circuit are operated. So as I said, some issues can be there, some malfunctioning can be there in the circuit breaker itself also, and these can come from the three different categories, that is from the insulation system, the operating mechanism, and the electrical and control signal. So the insulation medium may be the SF6 or the oil or the nitrogen gas density. Based on that, these are the irregularities can be there, or any general lockout can be there. Similarly, for mechanism also, we can have gas pressure, low hydraulic pressure, spring not charge, low air pressure, like that. Similarly, for control, AC supply fail, DC supply fail, pole discrepancy, auxiliary contact failure. These are kind of the issues we are encountering in our real-time power system, real-time breaker. So from all the uh, slides, whatever we have discussed, we have come across the breaker and the types of breaker, how it is functioning during normal and abnormal operating situations, what is the flow of operation, and the constructional details, the rating, the applications, and the functions, the circuitries involved. Next, we will analyze, like, it is the last line of defense of the power system. If relay detects a fault correctly, the system remains unprotected. If the breaker fails to operate, got my point? If the breaker fails to operate, whatever may be the relay, whatever may be the CT, whatever may be the PT, that goes in vain. Okay, so most of the circuit breakers, that their main job is to interrupt the fault current safely, and to maintain the circuit breaker in operation, we should have all the relay circuit cities and breakers to work as a coordinated system, not individually isolated systems. The regular timing test, contact resistance test, gas monitoring is very much essential for healthy breaker operation. Thank you for your patient hearing.